Welcome everybody to the Make Azure AI Real series, where we don't just talk AI, we do AI, and we happen to do it on Azure. Welcome to actually this is episode 4 technically, but I think maybe this is episode 3.5. I'm not sure. I have to like go back to the producers and see because this is actually part 2 of our responsible AI series. We had Ruth here yesterday, and again, if you're watching this on demand, it doesn't really matter yesterday, today, tomorrow, whenever. But if you weren't with us yesterday, stay here. You have missed something, but you could still watch us here today and catch the on demand for part 1 as well as part 2. But we were joined by Ruth, and guess what? We got Ruth back. Ruth, how are
Yay.
you doing?
Doing good, Corey. It's good to be back again.
Amazing. So, Ruth, I know if you remember last time, but we had a question to the audience. It was, what was your scary? What's the scariest movie you've ever seen? Because it was Halloween
Mhm.
then. Today is not Halloween, so we're gonna recover. Like anytime I watch a scary movie, I have to instantly go watch like a stand-up comedy after, just to kind of like rinse myself off and recover from being so scared. So,
That's a
what's the
good remedy.
yeah, it is. I'm not a doctor, but hey, I think it works. Great. So, what's the funniest movie you've ever seen? That's the question we have for you, Ruth, as well as to the audience. So, let us know funniest movie. I try to make these relevant to what we're going to talk about, but I think this is going to be relevant to what we talked about last time. But go ahead, Ruth. What's the funniest you've seen?
Man, you have like the most interesting questions to put people on the spot. Let's see. I'll say my cousin Vinny is
Oh,
one of
right.
my favorite. There are a lot of favorites, but my cousin Vinny is the one that sticks out because I feel like every scene I'm laughing at stitches. Yeah. How about
Nice.
you?
Very nice. That's tough. I think Super Bad probably is my the funniest movie I've seen, and largely because I actually like laughed in theaters. Like I do laugh. Like I'm not like not laughing, but I actually like legitimately laughed in theaters,
Uh-huh.
which is kind of a rare thing. So I think that
Yeah,
way,
that's
yeah,
a
it
good
hit,
one.
it hit. It came at the right time. It was like I think a summer. It was a perfect timing on that. But speaking
Yeah,
of
that's a
perfect
good one.
timing, speaking of perfect timing, a lot of people have joined here because they want to learn about responsible AI. Maybe they want to start building things, and it's quite popular to start building with generative AI, as you know. So if you are here on the stream, you've come at a great time because we actually just released generative AI 12-part lesson course, completely free on GitHub. You can just check out the link below, and let's see if we can time this right. The link is coming. The link is coming. The link below. There it is. Oh, perfect timing. So yeah, this
Oh,
that's
that's
actually the
a
other link.
different link.
Perfect
That's
timing,
for the
wrong link.
friend.
That's what you get when you do live. So we'll get the right link up there. I am almost sure of it. But yeah, so if you're interested in building with generative AI and also learning how to do it responsibly, so we have a lesson that Ruth contributed to as well. There's a link
Yeah.
where you can also check that out. But perfect. So Ruth, this is like I said, part 2, and you said you promised us last time that this was going to be the meat of what you're going to say. So we're gonna turn it
Yes.
over to you. And if we do get any funny movie recommendations, I'll put them. I'll post them here on the YouTube as you go on. But Ruth, take it away. Let's get to part 2.
Okay, awesome. So, thanks everyone for joining. As Corey mentioned, the topic for this series is how to train, debug, and deploy responsible AI models using Azure machine learning. So basically, yesterday, what we went through is how to train your model. This is a common question that a lot of people have that, okay, I see how the dashboard works, but how can I take the model that I custom trained and link it to the responsible AI dashboard? So that's what we covered yesterday, how to train the model, how to configure the dashboard to take your model, take your data, and generate the responsible AI model. So, as a refresher, just in case you weren't here yesterday, we're going to go through and talk about responsible AI and why is it important, and also talk a little bit about the dashboard before we get into the use case that we use to train our model. Sounds good? Okay.
Perfect. Yes, I think it sounds great.
Okay. So let's talk about the world today. When it comes to AI, we're seeing an acceleration of technology and breakthroughs in AI growing at a very rapid pace. When it comes to adoption, we see a lot of companies accelerating their adoption of AI. So they're allocating a lot of resource and investment into building AI solutions that they can use internally in their business processes and also their external consumer facing products to get a competitive edge. We're also seeing a lot of societal expectation increasing. Everybody is talking about AI, open AI, generative AI, and also in general, for the first time, a lot of people are talking about responsible AI. So kind of like Corey mentioned yesterday, everybody and their grandma
Yeah,
is talking about responsible AI, and we're like, grandma, not you too. So another thing that is evolving is we're seeing governments step in more to regulate AI in response. So that's um, the increasing demand for responsible AI that we're seeing. So when we talk about responsible AI, the question is, what is it? Is it a slogan? You hear of ethical AI. You hear a whole bunch of stuff. Um, we're going to get into talking about when, especially for Microsoft, when we're talking about responsible AI, what principles are we talking about? So the first principle is fairness. So under fairness is basically when you're creating AI solutions, making sure it is fair across people. So you're giving the same weight of um, usage amongst people. So if you have two people with similar attributes, the model should behave the same equally. Another area is reliability. So when you build your AI solution, how is it reliable? How is it safe for people to utilize? Is it consistent in its performance? How does it behave in normal situation and abnormal situations? That sort of thing. The next thing that's super important is privacy. So similar to other areas where we talk about privacy, this is also needed for responsible AI. So number one, when we getting data in general to train AI models is hard. So the question is, as we're training our models, we have to think, okay, where are we getting our data from? Is it from a credible source? And if it's from a credible source, is it complete? Just because you have terabytes of data, does that mean it's covering every demographic? So that's one thing. Well, that doesn't quite fall into privacy, but that's still important. But as we're working with data, we also have to think, okay, are we respecting people's privacy? So just because you have access to data, do you have the right to utilize that data, that sort of thing? Then security is another area. So a prime example that is actually in the generative AI course that Corey mentioned about is around when we're generating prompts for generative AI. You may have like a jailbreak where somebody will come in there and manipulate the rules that you have in your prompt. And that would be a security breach that will cause the model to do things that are not supposed to do or retrieve information that it's not supposed to retrieve. So that's something we need to be mindful. Then another area is inclusiveness. So a lot of people always wonder, okay, inclusiveness, fairness, isn't that the same thing? Inclusiveness is just making sure when you're building your AI model, think of all the outliers possible out there. Think of who's going to be using it, and are you covering all the different use cases or demographic. A good example is there are a billion people with disabilities. The common go-to disabilities that sometimes we think about is maybe blindness or death or somebody being in a wheelchair. But almost every one of us may have a disability, whether it's color blindness or dyslexia, all sorts of things. So we have to be mindful when we're building our AI solution that we are thinking of all the possible outliers out there. Then we have transparency. It's a common thing when we build these models. It does perform, give predictions and whatnot, but AI models are a black box. So the question is when it makes a prediction or when we get an outcome, the question is how did the model go about making that outcome? Prime example is, okay, if I apply for a loan, I get rejected. If Corey applies for a loan and gets approved.
Thank you. Thank you, by the way.
You're not helping.
I'll take the loan.
But if the AI system rejects my loan, the question is, what were the attributes that Corey had that I was missing? So it should be able to show transparency and show that, okay, these are the areas that I missed that caused the AI system to reject my loan application. So that sort of thing. And also, now that we're talking about regulations and whatnot, when you get audited, that is also an area that you may want to show transparency, how the model is going about making decisions. Then the last thing is accountability. Accountability is, okay, if you build the model, AI models be ready to be accountable for the outcomes that the model produces. So with all of
I
that,
just wanted to say, I think it was a really great point that you made about not just about the amount of data, right? But like how, like where has it been collected? Because I mean, even tying this to generative AI, we see so much data being collected for training these large language models. And, some people say, oh, it's trained on the internet, but that's like, probably physically impossible to train everything on all the data on the internet. So it took a lot of data from certain sites, but who accesses those sites, who uses those sites. So it's always good to always ask that question. I think that was a really great point, that it's not just about the amount of data, but how does it represent the certain population.
Yeah, I think that's a good question that a lot of people, as we're using generative AI, we need to pay attention to because the data was collected everywhere scraped on the internet. So it does involve an extra eye to look at things before we just blindly put it out there. So I'm sure you guys are wondering, okay, these principles are great. I do agree that I do not want to build bias models, but what does that have to do with me? So one of the things, the challenges that data scientists or AI developers face is, okay, I do understand that these principles are real, but how can I actually apply this to my everyday job? I am already training my model and looking at the performance metrics. Isn't that good enough? So those are gaps that data scientists have. How can we get the right tooling? The next thing is enabling decision makers. Decision makers rely on a lot of AI solutions to make decisions. So we need to be able to provide credible or reliable AI solutions so they are making the best decisions out there. So that's one of the important things. Then, the AI models that we put out there, it needs to gain people's trust. If we put AI model that is not fair or does not meet any of those principles, it's gonna tarnish people's, um, well, the business's reputation and also people's confidence in the AI solution. So kind of like how I mentioned, we're used to traditional metrics. We do look at things like accuracy. We look at the mean square error. So if we're looking at all these performance metrics, isn't that good enough? If my model says it's 93% accurate, isn't that good? The question is, what about the 7% that is not accurate? Is it a major demographic that we're leaving out? So we have to be mindful that some of the traditional metrics would not catch something like when you're not being inclusive or where there are certain biases in your model. So to put things into perspective, these are some of the common gaps that we have when we're using the traditional performance metrics. Similar to what I was just mentioning, you have an AI model after you do your performance metric evaluation, you see that, okay, it's 80% accurate. So we're excited. It's like, okay, let's deploy this depending on the use case. But we're not aware that maybe 42% of the demographic in the population, the model is failing, or maybe there's 59% of the demographic in our data that the model fails, and maybe there's a demographic that they're good, that the model is always accurate, even though the overall accuracy says 89. So those are what we currently face. Then also another misconception is, okay, let's just throw a whole bunch of data. Do we have terabytes? Let's move to petabytes. That would eliminate the bias. But at the end of the day, we have to look at the data representation. Do you have an overrepresentation in certain demographics and certain other demographics of your data set? You have an underrepresentation. Once you have that type of imbalance in data, that's when the biases start creeping in. Then, kind of like how I mentioned, the AI model is a black box. So figuring out, okay, what is driving the model's prediction is very important for transparency. And even debugging. When we're debugging, we also have to understand it, catch those driving factors if they're biases before we deploy it. And if somebody's auditing you, those are areas that you can show transparency. So similar to what I mentioned, one of the bottlenecks or one of the pain points that data scientists have and AI developers have is, okay, I understand all of this. It's important, but what are the toolings out there that will help me identify issues? So the good thing is researchers and organizations out there, and Microsoft researchers have contributed to several of the open source tooling that are available for people to utilize. So FairLearn is an example, Interpret ML, error analysis, Econ ML, and so on. So all of these are different good and useful tooling. The problem is when you have your AI model using these tools, you may need to be debugging your model in silos, not knowing that some of the information is not very easy to draw a conclusion. Sometimes you need to get a bigger picture. So the good thing that Microsoft has done is put all of those toolings into one dashboard. It's accumulation of all the open source tooling, and it helps. It's an interactive user interface dashboard. So it helps you uncover like error analysis, where the areas that the model is not performing well. Data exploration will uncover like the data imbalances, looking at the overall model performance, looking at fairness assessment, doing model interpretability, and counterfactuals. We're not going to get into counterfactuals today, but it's a very good area because sometimes you have a model, but you may want to check that, okay, if I change certain attributes about this model, what is going to be the outcome? So you want to know, okay, how does the model behave in certain situations? So that's also good, especially in the case of like, let's say a loan application. If I get denied, the question is, what do I need to do? So maybe if it's based on somebody's salary, it's like, okay, let's change your salary and see whether the model would increase it. Or let's change your credit score and see whether you will be approved for a loan. It also has different, another feature, causal analysis. So this one is mostly for business decision makers. It enables them to answer questions. So let's say you're rolling out a experimental drug. You want to know how people will react to it. Instead of putting A/B testing and trying to predict how the end user would do, you kind of, the dashboard gives you the ability to take your data and change certain things and tell you, okay, you need to increase this, you need to decrease this in order to get a certain outcome. So those are the areas of the dashboard.
And the
So now,
counterfactual, Ruth,
what?
the counterfactual what ifs, that doesn't require any additional training, right? That's just really tweaking the inputs or what the like to make a different type of prediction. Is that right?
You're right, because the counterfactual, you can tell it that, okay, this is a prediction that the model made. Can you generate like 10 different alternatives? So you can see it generates the different alternatives, and you can see, okay, what are the situations, let's say a loan approval, that this person can get a loan approval. So it will show that, okay, under credit score, it needs to increase to this amount, that sort of thing. So
Nice.
it's kind of good. And you can also change the values too to see what threshold the end user needs to be at.
Got it.
All right. So we are ready to look at the demo. of the use case that we trained the model yesterday. So for those of you that were not here yesterday, what we did was train a classification model. And basically what it's doing is using a data set from University of California, Irvine, and it's on diabetes patients. And basically what the model is trying to predict is whether or not when the patient is discharged from the hospital, what is the probability of them returning back to the hospital within 30 days? So are they going to be readmitted or not readmitted back to the hospital? Excuse me, my voice is getting dry. Okay, so we can get started. So when you train your model, the last step of the model was registering your model. So when you register your model, if you go to the Azure Machine Learning Studio, under models, you'll be able to see the different models that you trained. So let's say I picked that one. There'll be details about your model, but the feature within Azure Machine Learning Studio is you can click on the responsible AI, and with that, you click on the name of the dashboard you created, given that you submitted your model and your data set, and also the type of model that you use to train your model. So the very first section that we're going to go through is the error analysis. So with the error analysis, what it does, if we can zoom in to the screen, that'll be good. So people can see.
I think you might have to zoom in on your side. I don't think they can zoom in.
Okay.
Hmm.
Okay, that's fine. So on the error analysis dashboard, basically what it does is it shows like a tree of the top features in your model, and it's kind of color coordinated. So the darker the red shows areas where there's a higher error rate. So as you see the color getting lighter and lighter, there are errors, but the error rate is lower. Then when it's gray, it's okay, the model is performing well. So for the model that we trained yesterday, another thing is we provided the test cases, the data set for the test. So what the dashboard did was evaluate the test data with your model. So when it did its evaluation, it used 396 total records. That's the number of records that were in our data set. And it found that there were 584 correct and 112 records incorrect. So the root node is basically the total number of data that you had in your data set, and it also shows how many it got incorrect. So as you go at each node, the number on the right is always the total number with that particular use case. Thank you. Let's see, let me click on it. Forgot I'm dealing with multiple windows. So if we click on it, we'll see that, okay, for this node, in our data set is showing that, okay, for patients that had a prior hospitalization greater than 0, so that means you did have spent time in the hospital before. For that demographic, it looks like we have 204 cases of patients that fall under that criteria. And under that criteria, the model got those patients' prediction 57 incorrect. Then if we click on another node, it shows a number of lab procedures. So patients that had a number of lab procedures while they were at the hospital greater than 56, it looks like that's another area where there's a high error rate. So when you look at the path leading up to the root node, is actually a combination of patients that had prior inpatient, so they stayed at the hospital before, and prior lab work. Those are the ones with the highest rate. So you can click around the tree to see the different distribution, how the model is performing for different demographic. If we look at the far left-hand side, you see that, okay, this is a path that the model is performing very well. And those are patients that had no prior hospitalization, and most, it looks like the ones that are doing well are female, and the number of procedures, lab procedures, is less than 9. So when you're trying to figure out, okay, how should I debug this model? The best way to start is look at the path that has like the highest error rate. So the one with the darkest, will say that's the one with the highest error rate. So what you do is click on the root node and save that group or cohort. So I'm going to give it a name, error. Number lab work greater than, let's say, 56. And prior hospitalization or inpatient greater than 0.
I'm very impressed you were able to type all that and talk. I don't have those skills.
Yeah, I'm trying to find all of that. Okay, so we have the one with the highest error rate. Okay, so now we're saved the one with the lowest error rate. So this one is going to be longer, but bear with me. This is the boring part. So num lab work, let's say less than 9, and gender equals female, and prior hospitalization is less than, it says equal to 0. It's less than equal to 0. So we'll save that. So those are going to be the cohorts that we're going to be looking at. I'm sure you asked, okay, why are we creating these groups? What we're trying to figure out is, okay, what is it? Why is this group of patients performing, the model performing very bad? And what is so special about this group of patients? So you can compare and try and narrow down some of the features that are causing your model not to perform very well. Another feature that's also useful is the feature list. So the feature list is also another way of seeing, okay, what are the top features that are contributing to the errors? So you can look prior inpatient, the number of lab work, age, and race. So that will also help you debug, create other groups to debug. Another feature is called, let's see, I'm looking off the screen because that's where the navigation is. It's called heat map. So the good thing about heat map is maybe there's a combination or a certain field that you want to drill down to. So since age was one of the a sensitive feature that was contributing to the errors, let's look at what's going on with age. So the age is broken down to patients that are 30 years or younger, or between 30 and 60 years old, or over 60 years old. So these are diabetes patients. So if we hover over 30 years or younger, we see that the error rate is 14.29%. That's basically the ratio between in that demographic of patients that fall in that age group, the number of correct versus the number of incorrect predictions that the model made. The top number, the error coverage, is what percent of the overall total errors that we got. Remember the tree node, the very root of it. I think we had 112 errors. So what percentage of this demographic errors is contributing to that? So you see it's barely contributing. So this is not something that we should worry about. That is not displayed. So let me click on it. Okay. So for this node, we see that, okay, the error rate is 13%, which is not too bad. The coverage of percentage of overall coverage of errors is 24%. So that's not too bad. So we can dismiss that. So let's look at patients that are over 60 years old. So the interesting thing is the error rate is 17.47% between patients that fall under the age 60 and above. The model found when you look at the distribution between the correct and incorrect, this is a ratio, 17%, which is reasonable. But when we look at the overall error coverage, it looks like this demographic of patients are contributing to the total errors, which is 83 incorrect predictions compared to the 112%. So we know that this demographic is actually one of the key contributors. So the good thing is you can highlight on that or highlight each and every one if you want to analyze any further, and click the save button and do some further analysis. So
So we only have about 15 minutes left, Ruth. I wanted to show. Could you also see? I think on that. I think you went away on the view, but how many of those individuals that are over 60, like the number of individuals there?
yes. So over 60, let's highlight that. So it looks like it's covering it. But, oh, actually we can see it here. It's 475 total. So that's a good thing about this pane. When we select different groups, we can look at the stats over here as well.
Yeah, that's really good. I think I'm putting on my little, data skeptic hat and just saying, oh, well, it's because there's not many over 60 people, and that's why it's such a hard, cohort to manage or something like that. But I think this really gives visibility to all those certain points that you need to do to make sure that, again, the decision of is this in a responsible model or not.
Yeah. So that's a good point to make. We also have to consider the use case of, um, like diabetes. Which age group is more prone to getting diabetes? So that also plays into the factor of the use case. So when we look at, we're pretty much done with the error analysis. Error analysis, what it helps you do is to identify areas where your model is performing well and not well. So that's a key point. The good thing is we also have another section that's called the model overview. The model overview covers, gives you an overview of the different groups that you created. So disregard the temporary cohort that was generated automatically by the dashboard. But we need to look at all the data. So all the data set that we had, it looks like the number of accuracy is 83%, which is good. The demographic of patients that had lab work greater than 56 and the ones that had more than one hospitalization, it looks like the accuracy is 59%. So that also confirms the reason why the model is not performing well. Also, for the demographic that's performing very well, it looks like every data the model got correct. Another thing that you can look at is looking at the sample size. So this is a sample size out of all of the 396. How many patients fall within this demographic and how many patients fall within that demographic? In this use case, it's a small number. So you have to also take into account as you're debugging, is that demographic large that's having errors, or is it small? Those are things that you should take into consideration. Then you can also look at things like false positives and false negatives. So as we can see, it looks like for the most part, the model is incorrectly predicting the number of patients that would be readmitted back to the hospital versus the ones that are not readmitted. Another good thing is all the different cohorts that or groups that you created to compare their performance. You can see, okay, for the ones that in your data set that are not going to be readmitted, you can see that, okay, what the performance were in terms of accuracy. So you see that overall, the one that was performing very well, the model is doing very well. The one that has the error rate, hospitalization and more lab work is performing a little less. So those are areas that you can utilize to do some analysis. You can also look at different metrics in your cohort. You can look at accuracy. It looks for the most part that all the data is performing well, and the cohort of patients where the lab work is less than 5, they're female and have no hospitalization, they're performing well. So this can be misleading because when we start looking at things like precision, the ones that the model is predicting that would not be readmitted, it looks like it's incorrect. It's not doing so well. And when we look at the recall, we see that the predictions that the model is making that these patients are not going to be readmitted, they're actually going to be readmitted. So we can see that the model is really not performing very well. So you can also look at the confusion matrix and see, okay, the proportion of patients that are not readmitted versus readmitted. And you can see based upon the breakdown, um, the ones that are not readmitted, the model is not performing very well. So that's the gist of comparing the different groups that you want to debug, and you can create as many groups or cohorts that you want. But as you're looking at some of these data, you may want to look at certain features because, okay, what's the common denominator? Does prior hospitalization make any difference? So you can actually go on a feature level and maybe select one feature, like do some isolation testing and say, okay, let's look at the demographic of patients that had prior patient. So they had prior hospitalization. So the ones that had less than four, stayed in the hospital less than 4 times, seem like, okay, they're the majority. And the ones that had more than four, more than three, and less than eight, is another demographic. So you can also look at how the size and also how the breakdown of how the model is doing its prediction. So the same capabilities that are for the bigger cohort, you can also break it down to the feature cohorts. You can see that the ones that had less hospitalization, the model's performing really well. The ones that have between 3 and 6, I'll say 7 hospitalization, the model is not predicting correctly, and the number goes down in terms of if they're not going to be readmitted. So that concludes the looking how to debug the overall model performance using the performance metrics, traditional performance metrics that we already are used to. Another area is data analysis. So with data analysis, the good thing is now you can look at data. So the data view shows you the actual data in your data set. So this is all the data. If I want to look at, okay, the ones that are not the group that the model is not performing very well, I can switch and look at that cohort, but it shows you what the true prediction should have been. And it shows you what the model's prediction is. So you can kind of eyeball and scroll through and look at the data. And you can also look at the ones that it got correct. Where most of the analysis comes in, sorry, my voice is drying up. Okay. So where you can do start doing your analysis is you can look at the data distribution, because we saw that there's a high rate of the model incorrectly predicting patients that would be readmitted. So the question is, what is the distribution between patients that are not readmitted versus readmitted? This is looking at the ones that had the highest error rate. So if we want to look at all the data, we can filter by that, which is good. You don't want a lot of your patients returning back to the dashboard. I said to the dashboard, returning back to the hospital. So that's good. But you can also change it to see, okay, what is the model's prediction? So it looks like the model, the prediction kind of went down. The model is really struggling making the right predictions for patients that need to be readmitted. So this is a problem because if there's a chance that somebody would be readmitted, the hospital would need to catch it early. So this is an issue. Another thing is when you're debugging, it's good to also look at sensitive features like let's say race. So in the data set that we have, what is the distribution? This is a sensitive feature. So we see that, okay, there are more Caucasians than African Americans and Hispanic. So you can see the race distribution and see what role race plays into the picture. So we can see already there's an imbalance in the distribution of patients that come to that the model is trained on. When it comes to the distribution of female versus male, it's not bad. It's fairly the same. Then when we look at the age group, this seems realistic. Patients that are less than 30 years old or younger, there's a smaller percentage. Patients that are middle age are a little more than patients over 60. There's more in that category. So the next thing we can do is also look at,
So Ruth, we have about 8 minutes left now. So maybe if there's another kind of section of the dashboard that you'd like to show, I think it would be best. You got a nice, I think you saw hashtag nice dashboard, which you liked, I guess. I like that comment.
Yeah. So yeah, I'm about to finish this. So basically, the imbalance that we're seeing, especially when you see an imbalance of distribution of different attributes, that's when the biases come from. Because let's say you have over concentration of Caucasians and African American, and you take this model and take it to maybe a demographic that is highly Hispanic, the model is not going to perform well. So this is how you start, as you start playing around, you start seeing that, okay, here are the issues that we need to deal with. So this leads to the final section that we're going to cover. Even though the dashboard has more features. So the next part is feature importance. This falls under transparency. So explainability and interpretability. So the dashboard, the good thing is it shows out of the groups that you created, it shows what are the top features that are driving the model's prediction. So as you scroll down, you look at all your data set. So it looks like overall, the prior hospitalization, the number of diagnosis, and where the person was discharged makes a difference into whether or not a patient is going to be readmitted. The next thing that you can also do is if you want to see what is driving the models, like a certain feature, like, okay, I want to see what the threshold is for certain, let's see, hang on, okay, let's pick number of diagnoses. So if you want to see what, for a given feature, what is the threshold that makes the model make one prediction versus another? We're trying to see, okay, what makes for the number of diagnoses, what will make the model make a not readmitted prediction. So we have a 0 axis, and we see that if the number of diagnoses is between 3 and 7, the model is going to make a prediction of the patient not being readmitted. But if they have other diagnoses besides having diabetes, more than 8, you see that it's going the opposite. So that means there are actually going to be readmitted. So these are other ways that you can look at different features and see whether, okay, how are they influencing the model's prediction. And also looking at these factors, the kind of like how I mentioned before, if you look at the top features, if anything seems odd, that should not be the driving factor. That's a key indicator that there may be something wrong with your model. Then finally, another thing that you can do, since these are individual patients, let's say for the model is getting these patients' predictions incorrect. So you can select any patient information, scroll down and see, okay, for that patient, what were the um, key features driving that prediction? So if you notice, inpatient stays consistent. Number of diagnosis was not in the major model, was not listed in the overall model prediction. Race was not a factor, but it seems like with this um, patient, they're African American, so race played a factor into their prediction. So these are some of the things that you can do with the model. We have not even cracked the surface, but this gives you an idea of how you can have a model that gives you overall performance prediction. But as you start going through the different sections, identifying the areas where it looks like there are high concentration of errors, looking at the performance metrics, it can uncover areas where there are issues with your models, and also looking at where there's overrepresentation or underrepresentation or data imbalance. Then under feature importance, you can also look at what's driving your model's behavior, good or bad, on a global level or on the individual level. So that is a quick snapshot of the demo. If we can get back to the slide, if you want to go a little more in depth, step by step, there's a step-by-step tutorial that you can utilize to train the model and actually debug the model, and also some of the sections that we did not cover and some of the features that we did not even cover in this section. Thank you.
Perfect. Well, that was, like you said, only a brief touch of what can be done in this dashboard. So do check out the link there to get the better understanding of everything. Sadly, we won't have a part 3 with Ruth. This is only part 1, part 2, but there's so much more you can explore. But I do want to say thank you, everyone who came. You could have been anywhere on the internet right now, but you spent an hour with us talking about responsible AI. So for that, we're truly grateful. And thank you, Ruth, for coming up for not 1, but 2 episodes of the Make Azure AI Real show.
Thanks for having me, Corey.
Bye, everyone. Have a good one.
Bye.